In the next two slides, we will show some examples of matrix algebra. Let's begin with example 1. AX is multiplied with D plus BX inverse equals to C. The first step is, what we do is that we multiply both sides by D plus BX. In doing so, we have gotten rid of D plus BX minus 1 on the left hand side, leaving us with AX. We have just used the property of inverse in this first step. We then use the distributive property of matrix product, and we are opening up the brackets CD plus CBX. Remember, here we are trying to solve for x. So we bring CBX to the left hand side and we get AX minus CBX. When we can group x, so we get A minus CB multiplied by x. Finally, we want to remove this term A minus CB on the left hand side. So we multiply on the left by A minus CB inverse on the left. We'll get rid of these terms, leaving us with x, and A minus CB minus 1 is left multiplying with CD on the previous term, showing us this is x. As a sanity check, I wrote some Matlab program to perform this operation. First, creating matrix of appropriate size, generating random matrices of different values, using these values here to calculate C. That means given A, B, D, and X, we can find C. And then we also estimate X based on these values A, B, C, and D found. Finally, to show that the answer is correct, X minus X estimate was a very small number, showing that our derivation was correct. So this is a brute force approach, basically to prove that our algebra was correct. In this example 2, we are given this expression is equals to identity. What we first do is to multiply the second term by its inverse. What it reduces is that on the left hand side, we are left with AX transpose. This is gone after we have multiplied with inverse, leaving us with D plus BX minus 1 transpose minus 1, as seen here. We proceed to operate on AX transpose using the property of transpose. We have X transpose, A transpose on the left hand side now. Using this relationship, A inverse transpose is equals to A transpose inverse. We now interchange this. We'll see that inverse followed by another inverse, we can cancel this away. In the next few steps, we are going to open up the brackets on the right hand side. Identity times D is identity times D, but the transpose is distributed in. Identity times BX transpose is X transpose B transpose. We want to collect the X terms together. We bring it to the other side. Now we have X transpose A transpose minus X transpose B transpose equals to identity times D transpose. Finally, we collect X transpose outside. We have X transpose bracket A transpose minus B transpose. We move this term to the right hand side, and we'll have X transpose equals to identity times D transpose multiplied by this term's inverse. So the question was solve for X. Basically, we are given A, D, B, and I. To see that we have gotten the correct expression, let us write some Matlab code, and again, let's create a simple 3 by 3 matrix with some random matrices, and then we proceed to find this equation. Once we have solved for X transpose, we can get X, because all we do is X transpose. Using the transpose operator, we'll get X. We want to check for I, that is, we will put all these values in this equation and see that whether we'll get an identity, and in this example, yes we do, showing that our algebra was correct. So there seems to be a lot of rules and algebra to remember. In fact, there's a whole book of them. You can take a look at these notes where many equations are given, and practicing scientists do not memorize most of them. We only memorize some of them, like these simple ones over here. Practicing engineers actually use many of these identities and use them and look them up only when necessary. With that, we are going to conclude that you can have a look at this matrix code book, which we have about over 70 pages of identity. With that, we have concluded 7.2.3. Thank you.